Hello, good afternoon, morning, or evening, whenever you're watching this. I promised in class that I would post up more practice with stoichiometry, and so that's what we're doing here. This video shouldn't be too long, possibly 10, 11 minutes, and I'm just going to work through a single example here. And so with stoichiometry, what we have to keep in mind is what we're focusing in on is being able to convert units. We're turning grams into moles, into particles, into atoms, or any kind of combination of those three units. Now, generally, what we'll be focusing on, the general pathway here, and I'm going to show you a little clip here because I'll link this in the description as well. The pathway is in general this. You're starting off with some kind of mass or some kind of particle or even some kind of mole, and you're gonna have to be able to convert that into a different type of mole, mass, particle, and eventually volume when we start talking about the gas laws and everything like that. So the biggest thing you're gonna need in order to get from A to B is this. In this video, he calls it the coefficient ratio. And the general idea is you have moles of A. You got to get rid of them. So put that unit on the bottom. Then put the thing you want on top, coefficient B in this case. This here, coefficient A and B, this is your mole ratio, right? For any given reaction, you'll have coefficients in front of it. And so that lets you turn moles of X into moles of Y. And that's your switching point, right? Where you switch from two different types of moles. And everything before that, you're trying to get to moles. And so in this example here, we have a reaction. And we want to determine the mass and the number of atoms of carbon dioxide. Go ahead and highlight this, bright yellow. There it is. And what do we have to start with? We got 454 grams of glucose. There is a reason I use this kind of reaction here. We've got glucose, C6H12O6. We've got 6 moles of oxygen, 6 CO2, 6 H2O. This is a very good reaction to work with because it's relevant to your lives. We want to be interested in how much carbon dioxide is produced when a pound of sugar is essentially burned. And this is something scientists like to do because we want to keep track of our carbon dioxide. And so we're going to have to determine both mass and number of atoms. So what do we start with? Let's just go ahead and insert a table. Let's do a 7 by 2. Now, for this, what we're going to start with is 454 grams. And actually, you know what? I'll do 2 tables. Let's go ahead and insert 2 tables, 7 by 2. And so in the first box, we want to put in what we have, right? Our starting amount. In this case, it's our 454 value. And so our starting value is in grams. And so this is a mass. We want to be able to turn this into the mass of CO2, so grams of CO2, and we also want the atoms of CO2. And so eventually, we're going to have to switch from grams of whatever we're starting with, glucose. We want to get it to moles of glucose. Let me see. Let's not do a table. Let's do this. We have our starting value in grams. We want to get it to, we want our unit here in moles. We want moles of glucose. And from there, that's when we start using the mole ratio and turn that into moles of CO2. And then after that, that's when we go ahead and either turn that into mass of CO2, right? That's measured in grams, or the number of atoms of CO2. And so we're basically going to be following 2 pathways here. We start off with our mass, in this case, mass of glucose. We're going to use the molar mass to turn that into just pure moles. use the mole ratio to turn that into moles of carbon dioxide. And then we're going to turn the moles of carbon dioxide into both the mass and the particle number. So let's get started. We have 454 grams of glucose. I'm going to write the chemical name, so that's C6H12O6. That's what we start with. We want to turn it into moles. So 1 mole on top. I'm just going to write glucose because it's the same thing. We want to turn into moles. And so here we start using the molar mass. The molar mass is just the mass of your chemicals, just added up. And so we've got 6 carbons. Let's put it this way. We've got 6 carbons. Each of those weigh 12. We've got 12 hydrogens. Each of those weigh 1. And we've got 6 oxygens. Each of those weigh 16. So we're going to take those and add them up. Where do I get these numbers from? 12, 1, 16. That's the periodic table. Oxygen by itself weighs 16. Hydrogen weighs 1. Carbon weighs 12. Oops, this one. And so we put what we want on top, and we want to turn our unit from grams into moles. We put the thing that we have, our mass, on the bottom. And so 6 times 12, 144. I'm not doing the math here. I have a calculator for that. So we've got 12 times 6 plus 12 plus, and I'll put this in parentheses, 16 times 6 in parentheses. So 96. And so our units will cancel out. We can move on to the next step. We turned our mass, our starting value is a mass. We turn that into moles. Next, we're going to switch from moles of X, in this case glucose, into moles of Y, CO2. Right? We're using the mole ratio. And so the mole ratio is your coefficient ratio. So if I look at this reaction, this is saying if I have 1 glucose, I'll make 6 CO2s. I need 6 oxygens for this reaction to happen, and I'll also make 6 water. And so my ratio tells me that 6 moles of CO2 6 moles of CO2 are made if I have 1 mole of glucose. Right? So I've now converted my number or my units from grams to moles of glucose, and now I'm at moles of carbon dioxide. Our last step here is to turn it into mass. And so that's what we'll do. We'll put 1 mole CO2 on bottom because that's the unit we already have. We don't care about this unit anymore. We're going to move on to mass. And so the mass of CO2, that's 12 plus 16 plus 16, which is equal to, I believe, 44. And so all we have to do now, let's see if I can do it this way. Go ahead and delete these 3 columns. What I have to do now is, let's see if I could insert a column off to the right. I'm trying to fit it so it's a little bit better here. Yeah, it doesn't quite work. Let's go ahead and insert a column to the left anyway. Oops, I meant right. So all we do now is take everything on top and multiply it together. 454 times 6 times 44 times 1. 454, oh, too much. 454 times 1 times 6 times 44. Let's go ahead and clear everything and try that again. 454 times 1 times 6 times 44. 119,856. Okay. We take that number and we divide it by everything on the bottom, which is really just 96. 1,248. So 1,248 grams CO2. And so we've determined the mass of CO2. If you take 454 grams of sugar, glucose, and you burn it, you make about 1,248 grams of CO2. Okay. So we figured out the first half. What we're going to do next is just kind of copy this, Control C, paste it. And instead of mass this time, we're looking for particles. So particles, or atoms in this case, that's just your definition of a mole. 1 mole of anything is 6.02 times 10 to the 23 particles or atoms of the stuff. And so we just did this part right here where we turn moles into a mass. And so you see you have the weight on top. That way the moles cancel out. What we're doing now is this other part where we have moles on bottom, just like here. But in this case, the number of atoms is 6.02. So 6 moles times 6.02 times 10 to the, whoops, what was that about? Times 10 to the 23rd atoms CO2. 1 mole of CO2 on the bottom. And so the units will cancel out. And now we just multiply everything on the top together and then divide it again by 96. So clear everything. 454 times 1 times 6 times 6.02 to the 23rd. It's a pretty large number. We go ahead and divide it by 96. And we've got our final answer. It has, let's see if I know this by heart here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. 1.71. That's weird. Why is this such a tiny? There you go. 1.71 times 10 to the 25 atoms CO2. And that's our final answer. And so you see here that the process for the first like 4 or 5 columns is essentially the same. 3 columns. First 3 columns is essentially the same. Only in the second half do we start shifting things around, but even not that much. And so every time we're doing this, we got to be asking ourselves a few questions, right? Our middle step is always this conversion of whatever we started with to whatever chemical we want to end with. Before that, we got to have the mass, and that lets us get rid of these units here, the gram unit. And then afterwards, it's just depending on what we want. If we want mass, well, we put mass on top. If you want atoms or particles, you put the atoms or particles on top. So hopefully this video is helpful to you, and I'll post up a few other resources on the Schoology page along with this video. Thank you for watching. Have a great rest of your day. Bye-bye.